The Australian Nationals of Featherweight Robot Combat is rapidly approaching, and is not an event I intend to miss. Loft, my flywheel flipper, scored in the top 8 sportsman class robots this year and has been invited to play off for first place against the other contenders. It'll need some major work to prepare. Reliability is paramount, with no room for failure. The drivetrain will be rebuilt completely to rectify previous issues of drag and wheel failures. A feedback system will be engineered to provide information to the driver about the flywheel mechanism, as well as reduce spin-up speed. Obliterator is my current open class feather and will be competing as well. It'll be detuned to fit under the Australian speed limits, as well as a drivetrain upgrade as the motors kept falling off. Sitting here, I've just recorded the video script. I'm about to get to editing the video. It's probably going to be a bit more chaotic than usual, as to get both of these machines done within the time period, I was doing 2 or 3 things at once, so it might not be as chronological as usual, but I've grouped things as best as possible. We'll see how it turns out. Hopefully you can understand exactly what's going on and learn something from it as usual. When competing recently in New Zealand, I found that Obliterator was a whole 500 grams underweight. The only logical move is to put all that weight into the weapon bar, aside from the little that's needed for the drive upgrades later. As a whole, the weapon assembly sits at just under 4.5 kilograms, which is the maximum allowed. New weapon blades were cut in Perth by Action Laser and shipped to me. Surprisingly, each of the regular bars only cost 56 Australian dollars a piece, the disc being 89. Bisalloy 450, or whatever these actually are, is commonly used in mining equipment, so it does make sense that it's so accessible in Perth of all places. You have here on the machine one of the bars. I'm going to bore out this internal surface. You can see off of the laser cutter, the finish isn't great. I'm sure there's a bit of a taper. You can see where the pierce happens. But I specified this bore to be smaller than it needs to be, knowing it has to be machined out. And I specified it to be a 60mm diameter bore. But you can see that the machine has told me that it's actually closer to 60.5. So that's worth keeping in mind. It has to end up as 61.5mm, I believe. So there's plenty of meat left there, but that's, there you go. There's a disadvantage to the laser cutting process. The advantage is that this bar was like 50 or 60 Australian dollars, which is absolutely stellar. So I can't really complain. First milling operation is done. You can see where the pierce actually overshot the contour, but yeah, I'm not at all worried. That'll be totally fine. You can see this is an old Obliterator hub. There you go. Wiggle in it, no play at all that I can feel. The first task for Loft is a new flywheel flipper controller, driven by the fact that I had roped this into being a final project for a uni subject. The intention was to have a pair of loading bars down each side of the robot that would fill up as the flywheel spools, alongside stall detection and other features. From speaking to some of the other people in the Australian combat robot community, been very helpful. They pointed out that this SSR probably needs a load, so just putting a multimeter across it might not work, which, fair enough, I had no clue. So I've pilfered yet another battery from the smoke alarms around my house and hooked a motor up to it, which should definitely be enough of a load. I have not tried this, just decided to hold it up, so we're going to see together. Plug it in. And there you go. Thank you very much, helpful Nick and Richard with that. We can move on. Excellent. We have further developments at the Broken Link Robotics smoke generating and microcontroller destroying department. Check this out. Hang on, once I get the bloody cable. Look at that. LEDs. Individually controlled. You're just applying a very basic library, of course. I've never done that before. Pretty sweet. Got to control the brightness next. I'm currently testing first bits of code on this robot. It's all propped up and whatnot, and I've unplugged the electromagnet so that there's no way that the flipper can fire. But I'm trying to spin up the flywheel. I just had a fun experience where the flywheel spun up and didn't stop spinning up when I told it to. So I turned the robot off with the switch. But there's so much energy that the flywheel regenerated through the motor to keep the entire system powered for like quite a while. You can see the Arduino starts to get unhappy because it doesn't have very good power. If I carefully spin up the flywheel a bit. That took a very long time to get running. It's using interrupts, just using regular digital inputs was not working, as in the, what's the method called? Digital read. That didn't work. Interrupts does work, which makes sense because it's spinning pretty fast. You can hear the pulsing, I'm sure. I've got to figure out why. I assume it's something to do with how it's producing the PWM signal if setting the LEDs takes a while. Okay, it's cool progress time. I've worked on stall detection for the flywheel because I want to substitute the VESC for a red brick. Now the VESC has current limiting and thermal max capabilities, whereas the red brick has none of those. The advantage is the red brick will make this spin up dramatically faster. So if it stalls, I want to know that for whatever reason. So if you have a look, this is just the current sort of flywheel dial, looking for the color of the LEDs, which we can bring a little bit closer. I would like to note that the drive, flywheel, and clutch are all disconnected for this test. This is just a software thing. If I tell the flywheel to move, 2 seconds later, it starts blinking red because it has not detected that the flywheel is spinning, but it wants to. And if I obviously turn that off, it'll come back. Again, 1, 2, there you go. Flywheel is stalled and it'll tell me. If I see this blinking red in competition, I am royally screwed, but we'll get to that point when we get there. Currently pulling apart Obliterator to get these out, and you see the motor moving. It's not meant to do that. That is the problem that these caps are meant to solve. Tie them to the frame, stop this from shearing off completely, but this happened a lot in competition and I really would like it to stop. Those magnets should look like that. Yeah, not great. Parts for Obliterator's upgrades were provided to me by PCBWay. All these parts are made of 6061 aluminium and fit within the tolerances set in the drawings. Bearings snapped into place with a gentle push, then spun freely. When ordering through their website and selecting the anodizing colour, one has an option of getting the part bead blasted or not, before the part is coated. I don't really know the difference between these methods, so I ordered both, and this is the result, with bead blasted on the left and mill finish on the right. The latter is much brighter, but one can see hints of the machining process. Something one needs to keep in mind is that the parts are literally put on a rack when coated, which can leave a mark such as the one seen here on the bottom plate. This is perfectly normal. The website asks for a drawing to specify where this mark should be placed if the appearance is sensitive. In order to fit the motor supporting brackets, we of course need to drill some holes for the posts to be threaded into, which don't currently exist. So just modifying the original part, of course, no need to make a brand new one. It should be apparent what these caps do, supporting the rear of the motor to keep the can from pulling off or shaking around. Aluminium tube stock is cut to length to act as crush tubes, leaving about 0.1mm of axial space above the motor to not crush it. Working on the robot, and we have a visitor.
These are huntsman spiders, if you happen to not know about them. They're pretty big and they kind of look scary, but they're actually very harmless and they eat all the other annoying stuff, so they're good to have around. As long as he doesn't jump on what I'm working on. The problem I'm currently dealing with regards to the wheels, cropped up at the last event of course, these bushings, allegedly brass or bronze or something, I'm not entirely sure, they're wearing down very quickly. I'm ending up with heaps of play on the drive axle, which is a hardened bolt of course. This is a good example. So they were a really good fit initially, but now, I don't know if you can see how much play there is there. And even the flange is starting to crack off at that inner edge. Been stamped of course by combat, but that's just how it goes. So I swapped in my last set of spares. I'll add some more grease. Hopefully it does another event. This is pretty tolerant to misalignment. The gears can mesh with quite a large amount of center to center variation. The inner bushing, of course, is wearing a lot faster than the outer one because that's where the radial loads come from. In the future, probably find a higher quality bushing. I'm still happy with bushings here. Bearings for loft, because there's so much like the tension on the belts and there's a lot more drag and stuff there. But for a simple two-wheel drive machine like this, I'm still happy with bushings.
To be permitted to fight in Australia, I'd have to drop the weapon speed down from 75 meters per second to below 60. As the weapon motor is considered sacred, this is done with a higher pulley ratio, as well as lowering the robot's battery voltage from 6 cells to 5.
Rightio. So the next item on my agenda is replacing I believe this is a Dean's connector, with an XT90 to the new batteries to make them fit. This is one of the old batteries in the robot. Now, of course, these batteries have a massive amount of power in them, and you've got to respect that. But if only cut one wire at a time, and you always insulate the second conductor, right? You only ever have one exposed conductor while you're soldering it. Nothing can really go wrong. So taking your time, being careful, always insulating the second conductor, this should all go just smoothly. So when I'm talking about insulating the second conductor, that moment is now, because I'm about to cut this second wire and then solder this to this, of course. Now, if the soldering iron bridges these two contacts, game over. These two contacts, same deal. So electrical tape, then there really shouldn't be anything that goes wrong if you're being sensible. Here we now have, after hopefully a process you just saw, the XT90 swapped battery cable. Again, slow process, using your head, no issues whatsoever. Obviously now I've got to do it a second time, but yeah, get to that. The plan for today, as much as possible, I want to get all the machining done for Obliterator done today, and there's not much wiring to do. Hopefully I can bend this, because this is going to be the sidearm. It's very thick and it didn't bend well last time. Previously it was black HDPE, which I believe has a bit of carbon in it, and that's what gives it the black colour. But it can also, that colouring can hide the fact that the plastic is recycled, and it cracked last time. And HDPE really shouldn't crack. So I've got white HDPE this time, which I don't believe can be recycled, because any extra colours, I don't know, maybe you can dye it out. That was the theory anyway. So it's going to be white now. It's going to be, try to bend it, but a lot of heat to keep the stresses out of it. decommutating or something at high speeds, but that's not great, is it? Spinning backwards, and I've got to fix that.
With that, Obliterator is pretty much ready for nationals. I really like the look of the white armour and tipped blade, as snow white machines are pretty uncommon because everyone has grubby hands all the time. With the reduced tip speed, spin-up time is now ludicrously fast, at about 2 seconds from still. Considering it's running the maximum weight, maximum speed allowed with a large diameter, that's pretty good. With the machine sorted, we can turn attention to Loft, which, with 4 days until competition, looks like this. To replace the brass pipe bushings, Loft will be getting ball bearings in its wheels to reduce the considerable drag it was experiencing. I wrote a whole spiel about this, but it seemed too clunky to speak out. Pause here if you want to read it. The wheels themselves have been toughened up with bores to drive screws through and take shear loads, to stop that failure from happening. What I've been working on and what you should have just seen me make were these 4 new axles for Loft's drivetrain. Now this is compared to the old one. The difference is that these are slightly larger diameter and obviously have that neck to fit into the actual frame. The old wheels had a brass tube for a wheel bushing, and the grease would get dry and this would bind up. There's so much drag, like the extra force from the belts and the like. It spins freely now, but yeah, it would build up so much drag and it would shear the wheels. So the new wheels have ball bearings, as you can see. So new axle with a better fit, spins great on there, and with an increase in the normal force as a result of the belt tension and the like, won't increase the drag much, whereas with the bushings it would.
a big difference between these bushings and the ones that were in Obliterator, like these, is these are really thin, and so if they get dinted or whatever, even during the cutting process, they end up crimping slightly on the shaft, and then they don't run evenly, and they rub in. This is also magnesium. I'm not sure what the characteristics are of brass running on magnesium, but it can't be too good. Anyhow, so that should be a big boon to the reliability of this drivetrain. Currently rebuilding Loft's drive gearboxes, of course. So you've got the bevel gear, that's got the D-bore in the shaft, and then there's some retaining compound to keep it from wiggling around and from rounding over. The bevel side of things has these shims. You can buy them cheap from China. They're like a 1mm shim, so just stacking a bunch of those for now. That could have been a tube, but you get the idea. Actually shimming the back of the gear, some of these shims, and also, where's it gone? You can buy little boxes of shims of various thicknesses. So these are 0.2mm thick, and I have a 0.1mm thick box as well, which means I can actually shim the bevel gears properly. Previously it was just PLA spacers, which was not a very good idea. So we've moved on from that. This should run a lot smoother. Hopefully the gears last a long time. And obviously we're swapping in the better motors, so the motors shouldn't shatter. All of the motors I've been using of this brand, the magnets are just falling out. And this is a Sportsman, right? This isn't an open class, it's a Sportsman machine, and the magnets are falling out. Not great. This is one of the completed drive gearboxes with the bevel gears. With the new shims, I'll get close to the camera. Very little play in the bevels, that's about right. They are also actually located correctly. And compared to the old one, see how freely that spins? The old ones just didn't do that. So I'm very happy that it's the same hardware, just done correctly, and it's all spinning well. So duplicate this, of course, on the second one, and reassemble the entire drivetrain. There you go. Here's a untouched versus new gearbox. You can see the difference, hopefully. No play in that shaft. It rocks, it turns, but no actual play. Whereas this one, you see how much movement there is in that? There you go. No good. Rebuild. The bearings themselves have clapped out. They're just crappy, cheap 608 bearings. Not especially surprised, but thankfully they are extremely cheap. You can see here the difference between a not burnt out motor and a burnt out one. See how these sets of phases have been burnt, and I'm pretty sure this is A clockwise, A anti-clockwise, then B, B, C, C, A, A, and that's why this phase and this phase is burnt out, but everything else seems okay, or at least not as bad. But yeah, you can see the difference in the luster. Taking another look at these motors, can you see where the wires go into the phases down there? See how this one's, the insulation's been, that's not focusing, been worn away? This one too, and this one as well, with like a solder blob in it or something. I'm confident they didn't start out like that. So why, how and why has that happened? Because I don't think the can touch that. Very strange. I have here the first of the assembled drive sides. It turns nice. There's obviously still some drag. These timing pulleys that are printed, it's a little bit tight on the belts, I'd say, but that's a lot better than it used to be. I reckon this will run great. After all that electrical work, this will be the first power on. You see if the flywheel spins, the clutch actuates, something doesn't pop, and that the drive still works, of course. So that is the clutch working. You probably can't see it, but it is. Click, and then opens, click, opens. And the flywheel spins. thankfully the machine is working pretty well after all those changes to it. It drives quite nicely. These wheels with their draft on them to help them get out of the mold, it's still riding on that point. It hasn't worn off yet, so it's pretty slidey, but I'm hoping that will be improved as soon as it hits a rough MDF floor that the arenas are usually featuring. The flywheel system is working reliably. I haven't had any issues with it yet. Likely will on competition day, but so far it's been good. Swapped in a new clutch plate. The VESC is still here. I'm going to swap it out for a red brick now and see how that improves spin up times, because it decommutated for me right here. It failed to start, and thankfully the lights told me it failed to start, which I'm glad that's working at least. But I would like it to not do that at all, if possible.
After removing the heatsink, I was able to fit the red brick in place of the VESC that used to sit there. This photo shows why the red brick is so capable, just 3 layers of MOSFETs. Thermal transfer is terrible, but the inrush capacity is very high. Now unrestrained, the flywheel spin-up was dramatically improved. Not sure why it's braking for the bottom 50% speed or so, but I'm told I can tune that out in the radio. This ESC has never started backwards for me, nor decommutated after flipping, so I'll probably run it for the event and have the VESC as a backup. Throttle limiting will be implemented to keep the motor from burning up. As mentioned, the motors in Loft and Obliterator had both lost magnets in operation. This was limited to the cheap red and black variety, but by constraining the rear of the can, the shock to the rotor might be higher. To assist this, gaps next to the magnets are filled with long set epoxy to keep them from moving.
For the first time, I am battle hardening motors, so just adding some epoxy between the magnets, sort of scrape it in, and then wipe out the inside with a rag and some acetone, and it comes out pretty well. So now I'm going to stick this on the lathe and have it spin slowly for the next, I don't know, half hour to make sure that that stuff doesn't go anywhere.
You can see here a new rotor on the left and one with the added epoxy on the right. It is common to mix in some filler to reduce the volume of epoxy used, but I just didn't have the time. Afterwards, I stripped both robots' drivetrains apart to harden their motors. This process took half a day to complete. Both robots were then weighed. Obliterator is sitting right at 13.6 kilos, which is the maximum, but Loft came in at 14 kilograms. This is not insignificant overshot on a machine that had already been well optimized. In case of this, I had purchased some titanium round bar to replace the steel rack bar at the back.
In weight-saving efforts, replacing the old steel shaft with a titanium one should save about 200 grams in that. Get these cool springs of chips out of the parting tool, which I think is pretty neat. Anyhow, it is currently Tuesday night. I have to make the video on Wednesday, and then I'm leaving on Thursday. So running out of time, looking at all of the circlip grooves machined into the shaft. Now the next bit, which is by far the worst bit, is going to be parting the titanium shaft. It can be a bit of a difficult material to work with. Parting is always a delicate operation, and I really mean delicate, because when it goes wrong it'll grab, and this whole tool just shatters in one like explosive motion. You know, it's not necessarily a hazard to you at this scale, but I need this really bad. I'm not going to push my luck any further. It's only a little bit left. I'm going to try to hacksaw it, and then I can finish it with a regular tool. Because this, I can feel it. It's starting to, it doesn't want to cut as well because the surface speed is lower. Eventually it might bite if this bends, and then it's all over. It's a little bit prettier than the previous shaft, isn't it? Because that one was made in a huge rush as well. I kept screwing it up. This one looks pretty good. I'll go fit it to the machine and we'll see how it is. What do you think? Not good enough? Apparently not. There you go, installed in the robot. Looking pretty good. Obviously ignore the bashed up pulley. Everything's fitting well, all the clips are in the right place. Happy with that.
There's more I could do to both of these robots, but have hit the point where you just gotta fire them. You can't keep optimizing them forever. Obliterator is in the best shape it's ever been, and Loft appears to be reliable enough to take on the other top 8 competitors for the Sportsman title. Until next time.